Today, we will see how do we simplify rational expressions? How can we simplify expressions that are written in fraction form? Now, the main idea here is that we are going to use the rule of exponents to simplify rational expressions. And one thing to always consider is that the answers, they always need to be written with positive exponents. So we will use the rule of exponents to rewrite the expression. And once you rewrite the expression, you got to remember that your answers need to be written in positive exponent form. So let's get started. Now, here's some examples here. First, let's concentrate in examples that are not really in fraction form. Now, the first example here is that we need to simplify the following rational expressions, which you will see on the next problems. And always remember to leave your answers with positive exponents. Okay, so let's remember some rules with the rule of exponents here. Now, the rule of exponents says if you have a parenthesis and you have an exponent, this exponent need to be distributed. You distribute this exponent, but you do distribute just to the exponents. And the form that you're going to distribute it to is by multiplication. So now we're going to have x negative 2 times 4, so that's negative 8, times x negative 3 times 4, so that's negative 12. So now this is what we have. You got to remember that your answers need to be written in positive exponent form. So on our previous videos, we saw that we have a negative. We can just bring it to the bottom. Notice that both of them are negatives. So both of them, I'm going to bring them to the bottom. So now we're going to have 1 over x to the 8 times x to the 12. Now that I have it in this form, the 1 doesn't change. And when you multiply, you got to add the exponents. So now this becomes x 8 plus 12, which is nothing more than, what is 1820? X to the 20. So here, some things to remember. If you have an exponent outside, as a parenthesis, it multiplies. If you have a negative, change it to a positive right away. And now you have a positive, you can use the rule of exponents. And here, because they're multiplying, you gotta add the exponents because they have the same base. And now that you do, you just simplify, and this is what you have. Is your answer written in positive form? Yes, it is, so we're good. So now let's actually start with examples that are written in fractions. This is the kind of problems that we want to simplify. Now notice that you have more than one variable here. So what I like to do is, if you have any negative, we're going to switch it to a positive, which in this case, all exponents are positive. So we'll skip that step. And then you got to concentrate on variables. Let's concentrate on the x first. X to the 8 on top, x to the third. They're really dividing here. Here the x's are being divided, and the rule of exponents says that if you're dividing, you have to subtract the exponents. So let's do that. And the subtraction happens where the highest exponent is located at. So we're still talking about fractions, so let me write the number. We're dividing, so it has to be a subtraction. The highest exponent is on top, so we can subtract x to the third to the top. So now this becomes x 8 minus 3. This will take care of the x's. So now let's look at the y's. Y's, they're dividing. Where's the highest exponent? The highest exponent on top. So that's where the subtraction takes place. So now we're going to have y 7 minus 4, because again, you're subtracting exponents. And there's nothing left on the bottom, so we're just going to place a 1. And now we simplify. X 8 minus 3, so that's 5. Y 7 minus 4, so that's 3. Over 1. But you don't really have to rewrite that over 1, so this is just x to the 5th, y to the 3rd. Notice that both the exponents are positive, so we're good. So this is our final answer. X to the 5th times y to the 3rd. Now let's look at example 3. Notice that there's a small difference in example 3 than example 2. Is that here we have an exponent that is negative. So if you have an exponent that is negative, what I like to do is just take care of that right away. So I know that one way for us to go from negative to positive is just to change its position. So if it's negative on top, if I bring it to the bottom, it will become positive. So let's rewrite our original. Y to the third, I can bring it to the bottom as positive. So that's y to the third. Y to the fourth was positive on the top, so I'm going to leave it on the top. Y to the sixth was positive on the bottom, so I'm going to leave it on the bottom. So all I did, I just moved that negative exponent to the bottom, because if I change its position, it becomes positive. And now we can start working. So what I like to do is, if you see anything that you can multiply by, do that right away. So I noticed that on the bottom, both of them are w's, they're multiplying. So what I can do, I can just add the exponents. So now this becomes y to the fourth plus multiplication, you add exponents, so that becomes w to the 9, because 3 plus 6 is 9. So now we have this, they have the same base, they're dividing now. So my rule says that I need to subtract them. Where is the subtraction going to take place? The highest exponents on the denominator, so that's where the subtraction is going to take place. So I can bring this w to the bottom as subtraction. So now this becomes, if I bring it to the bottom, there's a 1 on top. And now we have 1 w, 9 minus 4. And now this becomes w to the fifth. Your answer is written in positive form? Yes, it is. So we're done. We're good to go. So one thing to consider is that if you have a negative, just make it positive right away and then move on with the simplification. I'll always like to multiply first if it's possible and then leave the division at the end. So now let's look into more challenging problems here. Okay, so again, even though the expression seems more challenging, one thing that you should always get into the habit of is, if it has a negative, just make it positive. And those which are positive, just leave them as they are. So let's rewrite this whole expression and go one by one. 12, it's positive, so I'm going to leave it on top. 8 to the fifth, that's negative, so I can bring that to the bottom and make it positive. So that becomes 8 to the fifth, positive. I'm just going one by one. B to the 10, it's positive, so I'm going to leave it on the top. Oops, that's supposed to be a 10. 8, it's positive, so I'm going to leave it on the bottom. 8 to the third, that's negative, so I should bring it to the top. B to the second, that's already positive, so I'm going to leave it on the bottom. Excellent. So notice that all I did, I just went one by one, and those which had a negative, I just switched its position. Now that everything is positive, we can start thinking about how we can simplify this. Well, I mean, you don't really have to do it, but let me just rewrite this expression in order to make it nicer. You don't really have to, but just for visuals. Okay, so now we have this. Now, when everything is being multiplied, so you're allowed to change its positions. It's fine. Now, why did I write it this way? Because it makes our simplification easier. Because everything's kind of in order. So notice that everything is being divided. So let's divide some stuff here. 12 divided by 8. Is there a way for us to simplify that expression or that fraction? So here 12 divided by 8. We can simplify this as 3 halves. So that takes care of the numbers. So now, look at the a's. They're dividing, so this needs to be a subtraction. Where is the highest exponent? The highest exponent's on the bottom. So now, if I divide those a's, I'm going to have a 5 minus 3, because again, if they're dividing, you subtract the exponent, and the subtraction takes place where the highest exponent is located, so that takes care of the a's. So now look at the b's, they're still dividing. Where's the highest exponent? The highest exponent is on top, so if you're dividing, the rule says that you need to subtract the exponents. So that takes care of the b's. And now we just simplify. 3, 10 minus 2, so that's 8. 2, 5 minus 3, so that's 2. Let's rewrite that 8. That's better. Notice that all of my exponents are written in positive form, so that's my final answer. So let's look at our final example here. Now again, if you notice anything that is being written as a negative, well, let's just rewrite it as a positive. So go one by one, and if it has a negative exponent, make it positive. Let's go. 12, it's positive, so I'm going to rewrite it. A to the negative 2, that's negative, so I need to write as a positive. So I'm going to bring it to the bottom, so that becomes a to the second. B to the 9, it's already positive, so leave it where it is. All right. 30, it's positive, so I'm going to leave it where it is. A is positive, so I'm going to write it on the bottom. B is negative, so I'm going to bring it to the top as positive. All right, so let me just rewrite that without any spaces. All right, so this is what we have. Now, what do you notice about the exponents? Well, let's concentrate on the numbers first. Can we simplify 12 divided by 30? 12 to the 30, that's equal to just 2 divided by 5. So that means that in our problem here, this 12 divided by 30, I can just rewrite as 2 over 5. So that takes care of the numbers first. We don't really need this, I just did it. So we can see that 12 divided by 30, you can just write as 2/5. Now let's take care of those variables. Here notice that the b's are being multiplied, because when you have two variables next to each other, they're multiplication. So now they're multiplying, they have the same base, so I need to add the exponents. So now this becomes b, 9 plus 2. So that takes care of everything on the top. Now on the bottom, they're multiplying as well, so I can just add the exponents. Remember there's an imaginary 1 there. So now this becomes 8, 2 plus 1. And then you just simplify. So it becomes 2, b, b11, 5, 8, 3. Everything's been written positive exponents, so we're good. Notice that one of the key things in this kind of a problem is that you need to be organized. So try to have a routine, and that routine, the routine that I always like to follow is if you have any negatives, make it positive first. Now everything is positive. See if you can multiply anything. I notice that they can multiply here, so that becomes b to the 11. Multiplies that, notice that they're multiplying here, so that becomes a to the third. Can you divide these two? No, you can't, because they have different bases, and that's pretty much all you can do. So here's your entrance ticket. Try to simplify the following.